In this video, we're going to be talking about section 1.1 again, but we're going to do a little just continuation. This is going to be part 2. To start, I'd like you to do a warm-up, and as in all of my videos, if you're watching these for the first time, it'd be good for you to pause the video and try them yourself first. All right, so let's go ahead and find the slope. So I've got slope is equal to, I'll do 3 minus 1 over negative 6 minus, hey, wait a minute, I'm noticing something that negative 6 and negative 6 are the same number. And so I already know what's going on here. I already know this is a vertical line. You can see the math is going to help me with that conclusion. I'm going to get 3 minus 1 is 2, and I get 2 over 0, meaning my slope is undefined. So that's kind of an issue, and I've sort of broken my violation there. I've gone and done my math sideways, and I did not mean to. So I'm going to fix that. My slope becomes 2 over 0. My slope is undefined, or there's no slope, which kind of means if you don't, like, that needs to translate to something to you immediately, because there's nowhere to go if I keep trying to do the slope intercept of it all. And what we need to realize is either noticing it here, or when we notice, hey, wait a minute, those are the same number, that what I have is in fact a vertical line. I'm at negative 6 and up 1. I'm at negative 6 and up 3. I have myself a vertical line. And what do we know about that vertical line? Both of the x values are negative 6. So x equals negative 6. There's not really any math to do once you realize it's vertical. You just put down the answer. Okay, let's keep going. And then I think maybe I'll end up skipping this, maybe not. But let's go ahead and do it since it's here. Without referring to your notes, why don't you write down these 5 things? So pause the video and do that. Point slope. Slope intercept. General form. A and B can't be fractions. A has to be positive. A vertical line is always x equals some value. I'll just call it A. And a horizontal line is always going to be y equals some value. I'll call it B. And again, please note, I just sort of grabbed 2 random variables. A and B represent any real number in this case. All right, let's summarize 2 more items. We summarized all those formulas last time, but there's 2 more things we want to come back to. And the first one is, what does it mean? What do we know if 2 lines are parallel? We know that their slopes are going to be the same, so they're going to be equal. And that should make perfect sense. If we're talking about 2 lines being parallel, that means they're going the same direction. And what bit of information tells us the direction a line is heading? That would be the slope. So if we're parallel, we have to go up and over the same amount on both of the graphs, or they wouldn't be parallel. If 2 lines are perpendicular, then their slopes are. Now, if we sketched one, so here's a line, that's positive line. Anything perpendicular to it would have to be a negative line. And so I think it's safe to say that their slopes have to be opposites. But it's more than that. If you remember, they also have to be reciprocals of each other. So if 2 lines are perpendicular, then the slopes are opposite or negative reciprocals. I can do my math neat. I cannot write neat. I have bad handwriting. All right, opposite reciprocals. All right, so then we jump on to example number 4. Find the equation of the line that is parallel, and then we'll do perpendicular in a minute, parallel to the line x equals 2 and passes through the point 5, negative 7. Okay, So on part A, once you realize what's really happening here, there's not a lot of work to show. If we're parallel to the line x equals 2, we should recognize again that the line x equals 2 is vertical. And so that means our other line has to be vertical as well. And if it's passing through the point 5, -7, that means it has to be passing through the point 5 vertically, meaning x equals 5. If we're going to do perpendicular now for part B, we know that perpendicular to a vertical line has to be a horizontal line. And if it's passing through that point, it has to be y equals -7. If I kind of sketch that out for anybody who needs to see it, the line in question is x equals 2. That would be this line right here. Come on, change color on me. So there's the line we want to be parallel to, but I want to draw it parallel to this line through the point 5, -7. So I'm just going to estimate 5, -7. So 5, -7 sitting down here someplace. And so that means the line in part A is going to be the vertical line to make it parallel. And so it's x equals 5. And then perpendicular to the red line would make it horizontal. And so horizontal going through that point would have to be the line y equals -7. And that's what we got. Okay, and then we have example number 5. Basically do the same thing. All right, this time our line is a little more complicated, and so the only thing I care about this line is I just need its slope. Once I get its slope, then I don't need it anymore. Without knowing what this line looks like, again, the issue is I've got some 0.34 and I've got some line. My job is to find the equation of this line right here that's parallel. Notice, other than slope, I don't care. Like, I don't care what its y-intercept is. That has nothing to do with my line, right? And then when I do the one that's perpendicular, I don't care about anything on this given line except for its slope. So that's all I need out of this. So I'm going to put it in slope-intercept form to be able to figure out what its slope is. So I'm going to move the 2x over. I'm going to write the problem down. 2x minus 3y equals 6. So I'm going to subtract 2x. I'm not going to show myself subtracting 2x because at this level we should understand just by looking at the result about what happened. And then I'm going to divide by -3. And again, I'm not going to show that unless you need to be successful. That's going to make this a positive 2/3. And this is going to turn into a -2. Not that I even care, because the only thing I care about is this right here. So my slope is 2/3. So a parallel slope is going to be 2/3. My perpendicular slope is going to be -3/2. And then I don't need that line anymore. This line is done. So now I'm just going to take the 0.34 and I'm going to find the equation of the line. All right, so part A, I'm going to use this slope. So part A, I'm going to do y minus 4 equals m 2/3 y minus 3. Now I want to start normalizing that point slope formula is an answer. It says write the equation. It didn't specify. So technically that is an answer that will work. I don't know if it's a good idea for us to kind of not practice it. So maybe we should go ahead and continue. But again, technically speaking, if this was a test and I didn't specify, then I guess you got me. This technically works. But let's go ahead and finish it. And again, I'm not going to show every baby step. I'm just going to show the result of each step. The 3's will cancel. I'm left with 2. And then I'm going to add 4 to both sides. Adding 4 is going to be positive 2. Part B, Do the same thing, still use the same point. Now I'm going to grab the perpendicular slope. So y minus 4 again equals, this time, negative 3/2 x minus 3. Again, technically that's the answer. I'll go ahead and put it into slope intercept. Let's see. Let's not do too many steps at once. Y minus 4 equals negative 3/2 x plus 9/2. I'm going to add 4 to both sides, so I get negative 3/2 x. I'm adding 4. I need a common denominator with 2. So it'd be great if we get to a place where we can kind of just do that part in our head and realize that by multiplying the 4 by 2 over 2, that gives me 8/2, still 4. So I'm adding 8/2 to 9/2, which should give me 17/2. No shame in writing that out. So if you were writing that out, you have 9/2, and I'm adding 4 to it, right? And so the common denominator is, oh, I need a 1 under here. And the common denominator is going to be 2, so I'm going to multiply by 2 over 2. 9/2 plus 8/2, and that's the 17/2. Okay, that's the end of our notes for today. Let me know if you have any questions.